Alright, let's try to do some past paper question about force and motion. So I would like you to try the question starting from page 14 and the long question on page 15 as well. So pause the video now, try it out, and check the answers later on.
A few moments later.
Okay, first question. Which statement about mass of a falling object is correct? Decrease as it fall. Why is this even a question? The mass of a falling object, of course, stayed the same. Yeah, D is the correct answer. It should not equal to weight because later on when you try to learn, you know that weight actually equals to mass times gravitational acceleration m times g. So weight is actually a force, so not mass. Mass is in kg, so they would never be the same thing. It is measured in Newton, so yeah, no, like I said, mass is measured in kg, so answer is D. Next question, which of these can only be changed, alright, by a force? So direction of motion, yes. Mass, technically you can't change it. Okay, in theory you can say, hey, if I try to break this pen, for example, then the pen's mass will be changed. But then if you consider that it's still the same amount of particles that made up the pen, including whatever residue that I create or like anything, like it will still be the same amount of mass. So not really mass. You can change the shape, okay, because for example, rubber band, you can pull it, then the shape obviously is different. Speed, of course, you can accelerate using the force, and so the speed will change. So then, yeah, C, D, yeah, okay, so the answer is C then, I think, right? Yeah, mass is not. Okay. Okay, next question. There are two people, one is pulling to the left 200 Newton, one is pulling to the right 150, and it asks these two forces would equal to which of the following single force. So this is something similar to the tug of war simulation that we did, and obviously the two forces here will equal to 50 Newton to the left, so the answer is A simply. D, a ball is flung upward. Which effect does the force of gravity have on the ball? It will just produce a constant acceleration downward. That's gravity, isn't it? And just to remember that it is a constant. In the future, maybe you will be doing an experiment, you'll find out the acceleration is constant. So you can take my word for it first. Next, the long question. So here is a lorry, and then deliver liquid and drives away empty. So that means the mass is much less. Compare the acceleration of the empty tank with acceleration of the full tank for the same resultant force. So to deal with this kind of question, first of all, you must recall the relevant equation, and that is F equals to ma. So I will strongly recommend you to put it down somewhere. Okay, don't worry, you won't be deducted mark if you put down things like that. Marker will just look at like whatever you answer in the box. And so the next thing that you want to do is you want to see what has been changed. So it said the mass, okay, or maybe how about that? The mass is the one that gets changed, right? So think about when mass get decreased, that means for the empty tank, then with the same resultant force, right? So what I'll do is I'll put a downward arrow for M, and for F, since it's unchanged, so I'll put a cross, meaning that it doesn't change. And so if you look at the mathematical relationship, if this is a constant mass decrease, then A has to increase. So that means when for an empty tank, then the acceleration will be greater. The other way around will be, for a full tank, will be having less acceleration. So this will be the correct answer. Okay, so once again, you may think that, hey, this question is very simple, you can identify the answers directly. But I think in general, in the future, this is something that you want to pick up. Write down the equation, and try to draw the upward, downward arrow or a cross to indicate whether or not they increase, decrease, or a constant. And the next part is simply ask you to explain. So yeah, I think basically here is telling you the plan already. So what you can say about is, according to Newton's second law, okay, F equals to ma, and so for greater mass full, like you can phrase it, for the full tanker which is of a greater mass will or would have a smaller acceleration. Alright, given resultant force is the same. Because you really have to ensure that the force is the same, because I mean, in other scenario you may have a greater force, then the whole equation will be different in this case. Okay, next is probably just doing the calculation. So it said weight, this is the force, this is the resistive force, that means going backward. So if you try to draw a diagram, then that's the best I can draw for a lorry. Force is 6,000 Newton, backward force is 2,000 Newton, not in scale this time, I'm just lazy. The weight is 50,000 Newton, but then of course the car won't sink, so in theory there is reaction force as well, but then it doesn't really matter because we are trying to work out the horizontal movement. And so the only thing that you need to do is, first of all, of course, state the equation as usual. Don't try to substitute anything, just write the general equation first. F equals to ma. So for net force, here we've got 6,000 and 2,000, but then they're in opposite direction, so you have to minus them. Mass, you don't actually know from the question, but then you can take from the weight, because weight is 50,000, and so for the mass you can do 50,000 divide 10, okay, because, or you can do weight over g, because weight equals to mg, and so weight over g will equal to m. So weight is like the one that is given, g is 10 meter per second square, as you learned earlier, or you can take 9.81, but then in IGCSE I would say you can always take it as 10. So that would be for acceleration, and so that means 4,000 equals to 50,000 divide 10 times a, and so using your calculator, in fact the mass is 5,000 then, so 4,000 divide 5,000 give you 0.8 meter per second square. So make sure you put down the unit and write down the unit correctly as well.